Okay, good day, good people. Let us look at how to calculate the vector. Remember, we said the vector it has two things: magnitude and direction. On the previous video, we dealt with the naming of directions. We never dwelled into how to calculate the direction. On this one, we'll be dealing with how to calculate a vector. Now, when you calculate a vector, the first thing that you need to do is how to convert the given statement into a vector diagram or a schematic. You will be given a statement in words. Now you need to convert that statement to a schematic or a vector diagram. Then the schematic or the vector diagram will indicate for you which method to use in calculating the magnitude and the direction of the vector. For instance, if you are given the statement and you converted the statement into a vector diagram and you find that the vector diagram is a right angle, now in calculating the magnitude of the right angle, you will use the Pythagoras method. You will use the Pythagoras method to determine the magnitude. You will use Pythagoras method to determine or to calculate the magnitude. But that which will indicate for you which method to use, it is the vector diagram itself. The vector diagram will indicate for you which method to use. If you have converted the given statement into a vector diagram or schematic, and the schematic it gives you the right angle, you will use the Pythagoras to determine the magnitude. Pythagoras, here's the formula of Pythagoras. Alright, now in determining the direction of the right angle, you will use the trigonometrical function. In determining the direction, you will use what trigonometrical function to determine what direction. What are the trigonometrical function? It is SOHCAHTOA, but we will be mainly focusing on TOA. We will be using tan to determine the direction. Only if the given vector diagram, or rather the schematic, it is what? It is the right angle, then you will use the trigonometrical function to determine the direction. You will use the Pythagoras for magnitude, then you will use the trigonometrical function for direction. You will focus on tan, mainly on tan. We will use tan to determine direction instead of sine and cos, but we will use tan. Now another thing, the angle that you need to calculate in terms of your direction, it is always, you will calculate the angle of where you have started drawing your vector diagram or your schematic. For instance, let's say we are told that Jomo he's going north. You will make your Cartesian plate to indicate the direction of Jomo. He's going north. Right. Then you are told that then he goes east, right? Because Jomo he is bored. Then they would say to you, calculate the resultant. Right. Calculate the resultant. Calculate the resultant. Now, this is what I need to calculate here. Okay, the angle that I need to determine, it is this angle if I'm working with that triangle there, or it will be the bottom one if I've decided to work with this triangle. You always calculate the angle of where you have started. You can tell that this is where I have started with my projections of the vector diagram, converting the given statement into a vector diagram. The angle that I'll be calculating, it is either A or B. I'm just giving you an example, but we will deal with that later on. Alright, let's move on then. Now, if the given statement, after you have translated it, then it gives you a triangle like this. This triangle, we call it an oblique triangle or an obtuse triangle. It is called an oblique or an obtuse, oblique or an obtuse triangle. After you have converted the given statement into a vector diagram or schematic, then you land yourself with this diagram. Yeah? This diagram, it is called oblique. It is called an oblique triangle or an obtuse triangle. Another word for it, it is obtuse. Now you will use the cosine rule. You will use the cosine rule to determine the magnitude of the vector. If the schematic, it is oblique or obtuse, you will use the cosine rule to determine what the magnitude of the vector. Let's look at the cosine rule or the formula of cosine rule. Here's the formula of cosine rule here. Here's the formula of cosine rule. It will depend on the given information. Right. If they want you to calculate A, this is the formula, pending on your diagram. A, in this case, the fact that I'm looking at this diagram, they want me to calculate A. This would be A, looking at the first formula there. Then B would be this side, then C would be that side. Then the angle that I need to use, it is this angle here. For what? For that formula, right? It is this angle A or alpha. If I'm looking at B, this one, now it will be B. All right, I'm determining this side, looking at this diagram and these formulas, because the formulas were worked out based on this vector diagram here. B for this side, A, there it is, A there, then C, there it is, multiply by angle beta, that's the angle here that we need to use, beta. Then C, determining this side, C, determining this side, it is C squared equals to A, here's your A, plus your B, minus your 2AC cos, since while I'm working with C, multiply by cos theta there. Right, that's the formula that you'll be using for. That's the formula that you'll be using to calculate your cosine, to calculate the magnitude. If you are given what? An obtuse or oblique triangle. Now, in determining the direction of an obtuse or triangle, we will use the sine rule to determine what? The direction. And this is the formula of the sine rule. You can either use this one or this one. It doesn't matter, the answer would be the same, because this formula and this formula, it is the same. You can either use this formula here or denote it this way or this way. It doesn't matter, your answer would be the same and the correct one. This is the sine rule. The sine rule, we use it to determine the direction of what? Of an oblique triangle. We use the sine rule to determine what? The direction of an oblique triangle. Now, your vector diagram, it will be based on those two diagrams, either the right angle, it will be based on either the right angle, or it will be based on the oblique triangle. Those are the triangles that you'll be working with to determine the magnitude of the vector and the direction of the vector. Right, now let's look at the position, because here they want us to calculate the resultant, and in this case the resultant would be this one, right, would be this one here. On the right angle, the resultant would be this one, right? But you don't just assume that the fact that you are having this component and this component, you will just join the dot. That's where your resultant would be. It doesn't mean that when you are having this component here and that component there, you will just join the dots here. You'll just join the dots, and that's what they need you to work out this resultant. No. You always work out the position of the resultant, where your resultant should be. Now, in working out the position of the resultant, now after you have converted the given information into a vector diagram or schematic, you still have to determine the position, right? You still have to determine the position of the resultant. You don't assume it. Like I said, the fact that you are having the component and this component, then you assume that this is where your resultant would be. Then you start applying the Pythagoras in determining that. No. You always work out the position of the resultant. Now, we determine the position, or we determine the position by applying the parallelogram principles. We will determine the position of the resultant by applying what? Parallelogram principles. Let's look at the parallelogram principles a bit. Parallelogram principle says two sides, they must be the same and equal, right? Like we are having here. This is the parallelogram. Then parallelogram says 2. Here it should be 2. Parallelogram says 2. Right. It says two sides, they must be the same and equal, right? That is the first point. And it comes and say alternating angles are equal and opposite are equal. Now alternating angle, this angle alternates with this one, and it is what? It is equal. This angle, it is the same and equal with that one. Then it says opposite angles are equal as well. Now this angle, it is opposite to that angle. Now these angles, they are what? They are equal. Then it comes and it says three angles are equal, or three angles of the parallelograms are equal to 180 degrees years, of which this angle and this angle and this angle, they equal to 180 degrees. They equal to 180 degrees. Now this information will help you as well in determining the precise angle or the precise direction of your vector. Yeah? Now after you've either means, how do we then use the parallelogram to determine the position of the resultant? For instance, we are given the information here. Yeah? We are given the information. We are told that Jomo, he is hungry and he wants to buy something to eat, and KFC, it is north of Jomo's home. Boom. Jomo is going to KFC traveling at 60 kilometers per hour. 60 kilometers per hour. Right, 60 kilometers per hour. Then when Jomo is at KFC, Gidiboni calls, Jomo, can you buy me something to eat as well? I'm hungry. Then the statement continues to say, Gidiboni's house, it is east of KFC. Now Jomo is traveling to Gidiboni's house at what, let's say it's traveling at 20 kilometers per hour, right, to Kidiboni's home, ne? Right. When he was going to KFC, you can tell he was driving at 60 because he's hungry. Now, cause Kidiboni wants something to eat, now he's driving 20. This guy is not fair. But now, you are having this element and this component. You don't just join the dots here. You don't just join the dot and say this is where your resultant would be. You need to complete this vector diagram by applying what? Parallelogram. Parallelogram said two sides. They must be the same and equal. This side, it is the same and equal as this side. This side, it is the same and equal with that one. It then means you need to replicate that which you have written here to suit the principles of the parallelogram. It then means this side should be the same and equal as what? As this side. Right. He's heading which direction? East. Including this one, it must point where? East, to show that this side, it is the same and equal as what? As this one. This one must be the same and equal as what? This one. Heading where? North. Heading where? North. Right. Heading where? North. Boom. There we go. This side, it is now the same and equal as what? As that one. Now we continue to say parallelogram. You know, you need to apply parallelogram. You can tell here we've applied parallelogram. We've replicated the first part of the parallelogram. Now we had to replicate or complete it with the mirror image. Then for us to therefore establish the position, we need to apply what we call head-to-head or tail-to-tail method to establish what? The position of your resultant. If you can check, this is where the head-to-head is. This is where the tail-to-tail is. When you see the head-to-head and the tail-to-tail, you know that this is where your resultant should be. Now, you know that this is where the position of your resultant should be. Then you do what? You join the dots. You do what? You join the dots. That's where your resultant should be. You don't just thumb suck it. You don't just assume that I'm having a component here and a component there, then I just have to join the dots. No, you always work out the position of your resultant. You work it out using what? Parallelogram and a head-to-head or tail-to-tail method to establish the resultant or the position of the resultant. That's how you determine the position of your resultant. Please make note. Please make note. And of which I forgot to indicate this on the first video. Please make note. When given the direction in this manner of words, like on the given statement, they are saying easterly direction, westerly direction, southerly direction, or northerly direction. Please take note. Whenever they say easterly direction, it is the direction from east to west, like I've indicated here. If they are saying it's an easterly wind, you know that the wind is blowing from east to west. Now in exam, they might say to you, depict or write or draw the easterly direction. Then when they are saying write or depict the easterly direction, this is what you need to write here. This is what you need to write as I've written there, indicating to them that it is the direction from east to west. Now westerly direction, that means it will be from west to east. Then southerly direction, it will be the direction from south to north. Then northerly direction, it will be direction from north to south. That's how you will depict it. But obviously you need to indicate that this is your northeast, those cardinal points. You need to indicate them. You need to indicate those cardinal points, isn't it? You need to indicate them and write with an arrow to show that it is the direction blowing from west to east if they said westerly direction. Please make note of this. Make note of this here. All right. How we calculate the magnitude and direction of the vector? After converting, if we get the right angle, we apply the Pythagoras method to determine the magnitude. We apply or use the trigonometrical function to determine the direction. If it's an oblique, then we use the cosine rule for magnitude and the sine rule for direction. Like I said, you always calculate when coming to direction. You calculate the angle that you will be calculating. It is the angle of where you have started drawing your vector diagram, as you will be converting the given statement into a vector diagram or into a schematic. Where you have started writing, that's the angle that you need to calculate as your direction. Please make note. Right. In summarizing or in just recapping few things or emphasizing the few things, we use the 4 cardinal points of a compass when determining direction. This part, it deals with the naming of direction. It deals with the naming of direction like we did in the first video. We use 4 cardinal points of compass when determining direction. We name the cardinal closest to the cardinal first, or rather we name the cardinal is closest to the vector first, then the angle of deviation, then the other cardinal point. Now in naming the resultant and direction, it will be R at east 20 degrees north. If the vector it is close to east, it will be you will start with the magnitude of the vector 50 at east 20 degrees north. This is the naming that we'll be working with throughout your kinematic in relation to your vector. This is the naming that we'll be using here to denote, the vector and the direction. How do we then calculate the velocity? This I was supposed to have emphasized it when we were dealing with the definitions, the PDF that I've sent of definitions. This is the formula that we will be using to determine what velocity. V equals to displacement divided by time. The SI unit, you can either work with meters per second or kilometers per hour. Then this I've already explained. The naming, or when given funny words like easterly wind, this is the depiction of easterly wind. This is the depiction of westerly wind. This is the depiction of southerly wind, and this is the depiction of northerly wind. That's what we will be dealing with on kinematic. I'll be dropping another video on the application of that which we have spoke of here. How to calculate the magnitude and the direction of the magnitude of your vector. Thank you, good people.